Hi guys, welcome back. Hope you're doing good. My name is Adil Khan. I'm your chemistry teacher in Base Education Service Private Limited. So welcome to the new session of Bridge course. Hope all of you are doing good. Hope all of you are safe. So let's start the fresh session of Bridge course or introductory course. Before that, from the previous session, that is session number 5, we need to discuss the problems which I have given you. I will be writing the answers. Please match it. If you are unable to, if you still don't understand, you post it out on Cubase. We will help you out. So first question was, you need to find out the percentage of carbon in your glucose. So percentage of carbon in glucose, the formula was mass of the carbon by the total mass of glucose, that is C6H12O6 into 100. So this formula we know. So mass is 72 and total mass is 180 into 100. So when you calculate this, you get around 40 as the answer. So this is the percentage of carbon which is present in glucose. Second is, you need to find out the percentage of nitrogen in urea. For your knowledge, urea is NH2 C double bond O NH2. This is the first organic compound to be produced in the laboratory. So percentage of urea, percentage of nitrogen in urea. So I'm just writing 28 by your 60 into 100. That is giving 46.7% as the percentage of nitrogen in urea. Third was, you need to find out the percentage of oxygen which is present in oxalic acid. So oxalic acid is COOH, and COOH I have given you. So 64 by 90 into 100, 71%. The formula remains same, the mass of the oxygen by the total mass, whatever we take. Fourth one is, you need to find out the equivalent mass of sulfur in SCl2. So equivalent mass of sulfur you need to find out. So you know what it is. So it is molar mass by valency, you can write. Okay. Or since it is sulfur, you will be writing atomic mass by the valency. Atomic mass of sulfur is 32. And valency is 2. Why it is 2? Because Cl2 is 2 times. So to balance that, S2 minus basically it is. So it is 16. So the equivalent mass of sulfur is 16 in SCl2. Fifth one was, you need to find out the equivalent mass of your what I said? Acid. So you need to know the structure for that. Then only you can find it out, the basicity of this acid, that how many H plus ion is furnaceable. So the H linked to oxygen is furnaceable. So 3 H are there. So the basicity is 3. So H3PO4 is the formula. You are finding out equivalent mass. So molecular mass by valency, that is N. So molecular mass of this is how much? When you do calculation, it is 98 and 3H. So 32.7 is the equivalent mass. So these three are in percentage and these are equivalent mass. So gram equivalent. So these are the questions from your previous class, previous session topic. 3 questions on the percentage composition and 2 questions were there on your equivalent mass concept. So I hope you have understood well and good. That's it from the previous class. Today, we are going to start the next session. And what's this? Can you guess what it is? That's right. It is Mr. Mole. So we are not going to study the animal mole. We are going to study a unit in chemistry that is known as mole, which is used to measure the small things like electron, proton, and ions and all. So welcome to session number 6. We are going to start mole concept and Avogadro number. Okay. So session number 6, mole concept and Avogadro number. Basically, what is mole? Mole is a unit. So I will explain you when I will go inside it. So let's take it one by one. So mole concept and Avogadro number. So an atom, you know, it is the smallest particle of the matter. Matter is something which occupies space, has mass, offer resistance, and perceived by the sense organ. So an atom is the smallest particle of matter which may or may not have independent existence. So this point is important, that they may or they may not have independent existence. For example, if I write helium, it has an independent existence, whereas hydrogen I cannot write like this, because hydrogen is not stable in its atomic form on Earth's surface. It is stable like this in sun and stars. So I write molecule like this. So an atom is the smallest particle of matter which may or may not have independent existence. That is the meaning of that. They are so tiny, they are very small, that they cannot be counted and weighed. If suppose I ask you to count 1 mole of 1 gram of hydrogen, you cannot count or weigh it easily. So in our day-to-day life, we use the terms like dozens. We use the term like dozens means 12. Suppose I ask 1 dozen banana, it means 12 banana. 1 dozen dates means 12 dates. A pair of monkey means 2 monkeys. Century means 100. Similar to that, it also means there is something known as gross. So gross means 144. If I tell 1 gross of paper means 144 paper. If I tell ream, ream is also a quantity. So ream is nothing but 500. So they are technical terms which is present here, like dozen, pair, century. It has a meaning, are used to count the number of particles irrespective of nature. For example, if I tell 1 dozen banana means 12 banana. Now banana can be the big one or the small one, irrespective of that. I can tell 1 dozen of mango, 1 dozen of papaya. So their size is different, their properties are different, but the number is same. So basically these terms like dozen, pair, century, gross, and ream, they are basically a representative of a quantity. It represents a quantity. For example, 1 dozen banana means 12 banana, or 1 dozen apple means 12 apple, irrespective of the size and the weight and the properties. It doesn't refer to the number of the fruit or any other substance what you are measuring. It is just a quantity, not quality at all. Okay. Okay, so in a similar way, for counting number of atoms, molecules, or ion, which is extremely small, not visible to our naked eye, chemists use the unit mole. So just like a dozen, gross, ream, pair, century is a representative of a quantity, a particular number, mole is also a representative. It has no difference than dozen and all. So the term mole is come from a Latin word which means heap or pile. Basically, what is mole? So a mole is defined as the number of atoms present in 12 gram of carbon-12 isotope. So you can write like this. It is nothing but it is number of particles in 1 mole of any substance. Now particle can be electron, proton, or it can be ions, atom, molecule. And it is equal to number of atoms in 1 mole of carbon-12. That is the meaning of this. So 1 mole is defined like this. Number of particle in 1 mole is equal to number of atoms in 1 mole of carbon-12. Okay. And one thing, most of the time our students get confused. They believe that mole is nothing but molecule. So it is not equal to molecule. Please keep in mind, mole is not equal to molecule at all. So the number of atoms which is present in 12 gram of carbon-12 was experimentally found out to be this number. So in 12 gram of carbon-12 isotope, how many atoms are there? By experimental method, we got to know it is this much, and this number is also known as Avogadro number. Okay. So this is nothing but a number 6.02 into 10 to the power 23. You can write 6.022 also. So this is just a number. And it is written in a scientific notation. Scientific notation means you will be having a number. This is a number in which before decimal there will be one number, and there will be something raised to the power. It can be positive or negative. Here it is positive. This is known as scientific notation. So this is a representation of any huge number or a small number. Got it? Okay, let's move to the next topic. Now, Avogadro number was given by the scientist, Italian scientist. His name was Lorenzo Romano Amedeo Carlo Avogadro. Yes, it's a huge name. It is Lorenzo Romano Amedeo Carlo Avogadro. He has given this. He's an Italian scientist. In honor of his name, this number was given. Basically, he was the lawyer and the first physicist in the Italy at that point of time. But the name was not given by Avogadro. The name Avogadro number was given by another physicist. His name was John Perrin. Mr. John Perrin has given this number in the year 1909. So he has given the name of this number in 1909. It is on behalf of, this number was given in respect of Mr. Avogadro, but the name was coined by John Perrin, and he's a physicist. He's not a chemist, he's a physicist. In 1909, he has given this number. Okay. And Avogadro number is basically, it's a bridge. So there is a two type of world which is macroscopic, which is very big, like mountain, sea, water, trees, and there is a world which is microscopic, like bacteria, fungi, atoms, ions. So Avogadro number act as a bridge between both. So it create a bridge between macroscopic and microscopic world. So that's for your knowledge. Now 1 mole, whenever we tell 1 mole represent this number, just like 1 dozen represents the number 12. We can write it here 12 particle, or you can write 12 substance, 12 mango, 12 orange, 12 bananas, 12 potato, 12 tomato. Just like that, 1 mole is this number. And it is equal to this much particle. Particle is what? Particle can be atoms, molecules, ions, or any other subatomic particle. Subatomic particle means inside atom, the very small particle which is present, like electron, proton, neutron, etc. Now, how this number is represented, or what is the significance? If I tell 1 mole of hydrogen atom, which is equal to Avogadro number of hydrogen atom. So atom related with atom. So 1 molecule of hydrogen molecule. So this is hydrogen atom and this is hydrogen molecule. So 1 mole of hydrogen molecule. And remember that the unit of mole is mole. That's why you are writing mole. Don't think that there's a missing E. The unit of mole is mole. So 1 mole of hydrogen molecule is this much hydrogen molecule, Avogadro number of hydrogen molecule. 1 mole of potassium ion is basically a positive ion, K plus, is equal to the Avogadro number of potassium ion, and 1 mole of electron, so electron is represented as E minus, is equal to Avogadro number of electron. So basically, in nutshell, 1 dozen means 12, 1 mole means Avogadro number, and that number is 6.022 into 10 to the power 23. Any doubt in that? Now this number is so huge that we write 602 into 10 to the power 21. So this number is just like million, billion and all. It has a name. It is known as sectillion. So 10 to the power 21 is also known as sectillion. So when you write in scientific notation, you shift the decimal this side, it becomes 6.02 into 10 to the power 23 after that, just for your knowledge. Got it? So Avogadro number was given after the name of an Italian scientist or Italian person known as Mr. Amedeo Avogadro, but the name was coined by John Perrin in 1909. So after giving you the basic of mole concept and Avogadro number, let's move into molar mass. So we have already done molecular mass before. So basically, what is molar mass? Molar mass is the mass of 1 mole of a substance in gram. Again, it is the molar mass is the mass of 1 mole of a substance in gram. So molar mass has a formula. So molar mass, you can write it as given mass by your number of moles what is present there. Okay. So molar mass is the mass of 1 mole of a substance, and it depends on the type of the particle. So basically the mass of 1 mole atom of an element is exactly equal to the atomic mass in gram of that element. So this is in short definition of the molar mass, that is the mass of 1 mole of our element is exactly equal to the atomic mass in gram of that element. Okay. Example, if I take aluminium, then aluminium atomic mass is 27 AMU. Okay. So 1 mole of aluminium is represented as 27 AMU. And you know that previously I told you that 1 AMU is equal to 1.66 into 10 to the power minus 24 gram or minus 27 kg. So this is AMU, atomic mass unit term. In short, remember, molar mass is nothing but given mass by number of moles. So the unit will be, given mass will be in gram, and mole is mole. So this is written as gram per mole. This is the unit of your molar mass. Okay. Let's see a bit more about your molar mass. For example, 1 mole of aluminium atom contain 1 mole of aluminium atom contain, you know that this is nothing but 6.022 into 10 to the power 23 aluminium atom. Now mass of 1 atom of aluminium. So 1 atom of aluminium, 27 atomic mass, you know. So 27 AMU we write. And you know that AMU is nothing but this 1.66 into 10 to the power minus 24. So 27 into that we multiply. And at last, mass of 1 mole of aluminium. So here 1 mole of aluminium is this much, Avogadro number. Mass of 1 atom of aluminium is 27 into AMU. And mass of 1 mole of aluminium is nothing but 27 into AMU into Avogadro number. So when you multiply all this, it comes 26.9 something. So we round figure it and write 27 gram. This gives the proof that how you calculate your atomic mass of aluminium using your Avogadro number and AMU concept. Okay. So in first, 1 mole of aluminium contain Avogadro number. Mass of 1 atom of aluminium is 27 U. U value you know, so you multiply with that. Therefore, mass of 1 mole of an atom. So given mass into your number of moles, you can do it. The formula which I have given before, that is given mass by number of mole, you can use it to calculate this. Okay. Therefore, this is the atomic mass of the aluminium in gram, or it is the gram atomic mass or 1 gram of aluminium. So various terms are there. Atomic mass of aluminium you can tell in gram, because gram atomic mass, the word gram we are using, or it is gram atomic 1 gram atomic mass or 1 gram of aluminium. It means the same. More numericals on this and more in-depth concept on this we will be doing in some basic concept in the next chapter, the first chapter what we take in the first PUC for you. So till then you just do whatever we have done, and later we will go into much in depth. So this session number 6, I have divided into 2 parts. First was your mole concept and Avogadro introduction concept, and next we are going into the types of reaction. Before going to the type of reaction, I want to give you some trivia about Avogadro number, which I should have given you before. Now Avogadro number, that number 6.022 into 10 to the power 23. Suppose you go in the market and tell, you give me this much amount of chocolate, or 1 dozen of chocolate. 1 dozen chocolate you will get, but this much amount of chocolate you will not get, because they will not have this much. This number is so huge that if you have 1 mole of donut you know, right, all of you? So if you take 1 mole of your donuts, then it is equal to this much amount of donut. Now this much amount of donut is enough to cover entire earth to a depth of 8 kilometers. Yes, you heard me right. If you take 1 mole of donut, then the amount which is present in it, the number of donut, is equivalent to cover the entire earth to a depth of 8 kilometers. This is so huge number. Or if you take 1 mole of basketball, 1 mole of basketball, we can create a new planet of the size of earth. It is such a huge number. if you take 1 mole of basketball, we can create a new planet of the size of the Earth. Such a huge number it is. So just for your knowledge, this is such a huge number. It is not easy to calculate, but still hats off to the scientist and the chemist who has achieved this. So initially, when Mr. Avogadro gave this concept, the scientists at that point of time, they were not ready to accept it. But later, after 10-15 years, they agreed that Mr. Avogadro was right. And since then, Avogadro number is there for us. So just remember, mole is just a number which represents small substances, nothing else. And that number named is Avogadro number. Okay. Just like 1 dozen is 12 fixed, 1 mole is 6.022 into 10 to the power 23, it is fixed. That 12 doesn't have a specific name, but this number has a specific name known as Avogadro number. The name is coined by John Perrin. That's much you have to understand. Okay. Now moving to the next part of this chapter, we are going to discuss type of chemical reaction. What is chemical reaction? Basically, chemical reaction means there will be involvement of reactant and there will be production of the product. So reactant will be consumed and product will be produced, consumed and produced. And this reaction move in this direction. This arrow tells that reaction move from reactant side to product side. So whenever a chemical reaction take place, chemical, not physical, we see that in reactant bonds break. Okay, what is bonds? We will discuss later. You just remember that between 2 hydrogen molecule, there is 1 bond. Between 2 oxygen molecule, there is 2 bond. Between 3 nitrogen molecule, 3 bond. Bond means a thing which can hold 2 atoms together at this point of time. So in reactant, bonds break, and at the same thing in products, bonds form. So you can tell bond or bonds, bond break and bond form. So whenever in reactant, there is a breakage of bond and the formation of bond in the product, new bond, then that process is known as chemical change or chemical reaction. Now, during bond breaking and bond formation, energies are also required. Either energy you have to give or energy will come out. So everything we will see that in chemical reaction. So chemical reaction basically means when a reactant getting consumed into product by the use of energy or by giving out energy, and it is represented by a chemical equation. So chemical reactions are classified into many types, but for your level, we are doing 4 types at this point of time, but there are many more types other than this, which we will be doing in the first year and second year to maximum extent. So the first reaction is chemical combination reaction. Now, chemical combination reaction is what I can represent as reactant as A, reactant as B, combining to give me product AB. So here you use 2 reactant, or you can use more than 2 also, but to start we take 2 and it give rise to 1 product. It can give more than 1 product also, but initially 2 reactant giving rise to 1 product. Okay, so chemical combination reaction is what? It is the chemical change in which 2 or more substance combine to form a single new substance is known as chemical combination. Now, one important thing what you need to know here, this A and B combining to give AB. Now, this A and B can be element or and element. Okay. This A and B can be element or compound, or this can be compound plus compound. So 3 permutation combinations are there. Element combining with element to give a product. Okay. Element combining with compound to give a product, and compound combining with compound to give a product. We will see the example of each one of this. But representation of chemical combination is this. And one more thing extra which I am going to explain you here is during every chemical reaction, with some exceptions in it, generally in a chemical reaction, heat is out. So when product is produced, the amount of energy what product has is lesser than the amount of energy what reactant has. So if suppose a reactant has 50 kilojoules of energy, kilojoule is the unit of energy, the product energy will be 40 kilojoule. It means that some amount of energy is out. So basically, generally, with some exceptions, chemical combination reactions are exothermic in nature. So exothermic means, exo means out, thermic means heat. Heat is coming out. Remember that if a product has less amount of heat when compared to reactant, it is more stable. If you have less energy in you, you are more stable. If I give a layman example, if suppose this is a playground, I ask you to take one round of this ground one day. Second day, I ask you to take 10 round of the ground. In which of these cases you will be left with more energy after one round? But after taking 10 round, you are completely exhausted. So you don't have energy. So you are less reactive. If suppose a mad dog is in front of you, you will not react because you don't have energy to run and save yourself. So if the energy of the product or a substance itself is less, then that thing is known as stable. Less energy, higher stability. They are inversely related. Remember this at this point of time. Generally, exceptions are there. Generally, chemical reactions are exothermic in nature. Okay. Now let's take examples of these. So the chemical combination reaction may involve combination of two elements, which I have explained you. So here you see two elements are there. A hydrogen as an element itself and chlorine giving 2HCl, that is hydrogen chloride gas. Or combination of an element or a compound. So if you take PCl3 and Cl2, it is giving rise to PCl5. It is phosphorus pentachloride. Again, it is second type of it. And third, combination of two compounds to form a new compound. So ammonia and HCl forming ammonium chloride. This is a salt. So simple story, element and element combine to give you a compound. Element compound give you to form a compound, and compound combine to give you a more complex compound. So these are the example of your chemical combination reaction. Generally, the product energy is less, reaction is exothermic, and the products are stable. Okay, very good. Now let's move to the second reaction. It is opposite of your chemical combination reaction. It is chemical decomposition reaction. So chemical decomposition reaction means, suppose there is AB as the reactant, it will give rise to A plus B. Okay. Now here in the previous case, bonds generally are formed, but here you have to supply heat, and heat is represented as delta. When you supply heat, AB will break to give you AB. So in this case, heat is given inside, so heat is in. In the previous case, heat was out. The previous case was exothermic reaction, but this is endothermic reaction. Endothermic reaction means your heat is coming, your heat is going inside. Exothermic reaction means heat is coming out. Exo out, endo in. Thermic means heat. So basically this is your endothermic reaction. So in chemical combination reaction, a chemical change take place where a single substance like AB break into two or more simple substance is called as chemical decomposition. Now this A and B, either they can be an element or a compound, but one of them must be an inelemental form. Exceptions are there in that also. The simple substance may be two element, which I told you same thing here, or one or more element and more compounds to two or more than two compound. In simple statement, after breaking, either you will get two elements or one element and one compound, or both the compound. So generally we see majority of time one element will be produced. It is opposite of your chemical combination reaction, so you can understand accordingly. Okay. Now, chemical decomposition reaction is of a couple of types. The first one is a thermal decomposition reaction. Thermal means heat. Heat we represent as delta. So here we will be using heat to break it. So suppose you take calcium carbonate, which is a limestone. When you heat it, it forms calcium oxide and carbon dioxide. Okay, or you take potassium chlorate 2KClO3 in the presence of MnO2, manganese oxide, as a catalyst. When you heat 2KCl and oxygen, so here you see it is compound and element. So combinations are there, either you get element element, element compound, compound element. Generally for your level we focus on minimum one level of elemental form. So this is thermal decomposition using heat. One more type is there, electrolytic decomposition. Electrolytic uh, decomposition means we will be using current, which is also known as electricity. Electro means electron, and wherever there is flow of electron opposite side there will be current, and lytic means break. So breaking something with the presence of current is known as electrolytic or electrolysis. Decomposition. So decomposition of a substrate brought about by passing electric current. So you need to pass on the electric current through the aqueous solution or molten solution. So this only take place when the solution, when the substance inside in water, because that will help the reaction to be better because of segregation of ion. And in the molten form, molten means when you heat to melt it so that the lattice, the structure break. So when electric current is passed through water, it decomposes to produce hydrogen and oxygen. So if you can write capital I also. It looks simple, but it is not that simple reaction basically of water. So it is very complex. You will learn when we will teach you water in the coming inorganic chapter in standard 11th. Electrical decomposition has one more example here. So when you pass electric current through molten sodium chloride, molten means you have to heat it. It decomposes to give sodium metal and chlorine gas. Now you can see here two atoms, two elements are produced. Similarly, aluminium is extracted using Al2O3. This is nothing but known as alumina. You will read this in metallurgy chapter, by passing electricity through the molten Al2O3. So when you pass electricity through this, you see that 4Al and 3O2 is released out in a balanced chemical equation. So decomposition, chemical decomposition is two types, thermal and electrolytic. I have explained you both. One more is there, I thought to avoid, but I'm giving you now. It is known as your photolysis. So photolysis means what? Photo means light. Light, generally we talk here as a sunlight, and lysis means break. If you break something with sunlight or photon, photon means light, it is known as photolysis. It is also decomposition. Suppose I take silver chloride as salt and I heat it in the presence of sunlight. Sunlight is represented as H nu, or you can even write it as UV. Let's write sunlight only, so H nu. So when you heat this in the presence of sunlight, you see it break as silver element and chlorine gas. The upward arrow means chlorine gas is coming out. So this is your photolysis or photolytic decomposition reaction using sunlight, basically sunlight, but in lab we can use other form of sunlight with specific energy. So decomposition, three types, thermal, electrolytic, and photolysis. So please remember this. So two chemical reaction we have done. We are moving to the third type of chemical reaction, that is chemical displacement reaction. Most important out of two what we have done. Now this is basically a displacement reaction or a replacement reaction. So what do you mean by this? Suppose I have A as a reactant and B and C as the reactant. So what I see that A will go and react with C to give AC, and B is out. Now, why it is possible? It is possible because your A is more reactive. So you can call it as displacement or replacement reaction. And why it react with BC? The reason for that, B is less reactive. So generally, for your level, we tell a metal is replacing another metal. A highly reactive metal is replacing less reactive metal. So this reaction is represented like this. Okay. This is also known as substitution reaction. Or it is also known as single displacement reaction or single substitution reaction. Couple of names are there. So basically, we are dealing with metal replacing another metal, or reactive metal displacing another reactive metal. How to know which is reactive and less reactive? Next slide we will see when we'll see the reactivity series. Let's see the definition first. So a chemical reaction in which more reactive element means which has the tendency to give out electron more easily. That is the meaning of more reactive at this point of time. Displaces a less reactive element. Less reactive element means a metal or element which do not give out electron that easily. I'm talking with respect to metal only. That's why I'm telling give out electron. From its aqueous solution salt, solution is called chemical displacement. So replacement of less reactive metal with more reactive metal, or less reactive element with more reactive element, is known as chemical displacement reaction. Okay. Let's see this. So there is a reactivity series of some of the element in the following table. So this is known as metal reactivity series, or you can call it as activity series. So basically metals are of three types. Metals I told you we are dealing with, we are not talking about non-metals and all. There are three types of metal. One is there is highly reactive metal. Next is there is something known as less reactive metal. And there is something known as moderate reactive metal. Okay. Now, to differentiate this highly reactive example, if I take, I can talk lithium and sodium. Less reactive metal, if I take, I can talk, it is nothing but nickel and tin. And less reactive means I can talk with respect to gold and platinum. And moderate reactive means zinc and tin we can talk. So there are three types of element metals, basically highly reactive, less reactive, and moderate. Now there is a series in which they are arranged from high reactivity to low reactivity. So oxidation reaction and all you avoid, you don't know at present. Remember that lithium react faster by giving out electron easily. This is ease of, this is ease of reactivity. When you move from down to top, reactivity increases. When you move from top to bottom, reactivity decreases. Then potassium, barium, like that. Hydrogen is there in somewhere in the bottom. To differentiate more reactive side and less reactive side, moderate is somewhere here. So copper, silver, mercury, gold, platinum, they are basically less reactive. You remember here that the metals which is above hydrogen, they are reactive and they can react with the acid and replace hydrogen from it. The metals which are above hydrogen in this series are reactive and they will replace hydrogen from acid, whereas the metal which is below hydrogen are less reactive and they do not replace hydrogen from the acid. That much you have to remember at this point of time. Let me give you an example, then we will move forward. For example, when you see zinc is above. So if I write zinc and I write HCl, so what we will see basically zinc is Zn2+, so we'll write ZnCl2 and hydrogen gas will come out. So 2 zinc, we will be writing 2 HCl here. So since zinc is above hydrogen in reactivity series, it can react with acid and replace hydrogen. That is the meaning of that. Simultaneously, if I write silver and I write HCl, so generally we see that there is no reaction. The reaction do not take place. So here we tell this is more reactive and this is less reactive. Now metal also I will give. Just have some patience. So let's see some reaction. So I have already given you this, that zinc displaces or replaces hydrogen from dilute acid, as zinc is more reactive than hydrogen. How to know it is more reactive? It is above hydrogen in the reactivity series. In the similar way, copper sulfate and iron. Now iron displacement you see here. Now you see here. Copper is here, this is copper, and iron is here. Iron is above, so iron can easily replace copper. Anything which is above can replace copper. For example, calcium can replace magnesium, but magnesium cannot replace calcium. Okay, above can replace, below cannot replace above. So since copper is below and iron above, you can form this. But if we write iron sulfate, that is FeSO4, and I write copper, then there will be no reaction because iron is above. Copper cannot replace iron because it is below in the reactivity series. Okay. So in this process, copper get deposited on the iron and blue colored solution turn pale green. So copper sulfate is basically blue color solution, blue vitriol, with 5H2O. And this is green vitriol with 7H2O. So the blue color comes down and the green color increases. So this is your displacement reaction, which you know. Now let me give you one reaction and let's see whether you can write whether it can take place or not. Suppose I write silver and I write copper nitrate. Tell me the product. Tell me the product. Ag, 3 twice. Copper. Are you writing this? Ag plus in the form? Then your answer is no. So there will be no reaction in this case. Reason for that, silver is down and your copper is above that. So reaction do not take place. Whereas vice versa is possible. Silver nitrate and copper, it will react. I hope this is clear. Good. One more I am giving you. Let's see whether you can write or not. Suppose I take magnesium. It is present in chlorophyll also. When you treat with copper sulfate in water, that is aqueous form, tell me whether the reaction take place or not. So if you write magnesium sulfate and copper as solid, then you're right, my dear friend. Reason for that, magnesium is above somewhere here. Check this. This is magnesium and copper is down. So this is possible because you see here magnesium is above and copper is down. So magnesium can replace copper easily. So this is right. So you have to be very careful. You need to remember reactivity series. If you remember from this, what I have given you now, this one, you can memorize it well and good. You can make a song out of it. I have a song, but I will teach this in normal class, not here now. To memorize this. So basically I write it as Kala Cat, Naam Magnet, Alu Jeera, Firni Pila. That is my song, but not now. I will do it later when you join us in the classroom. This is all about your displacement reaction or substitution reaction or single displacement reaction. Let's move to another set of reaction. This is known as double displacement reaction. So the name only suggests double displacement. Previously, one element was replacing another element. Now here double displacement. So double displacement, you can write it like this: AB, CD. So AC will react and BD will react. Or you can write it as AD will react plus BC will react. Now here what is important is that suppose this is A plus cation. This must be in the aqueous solution. They are basically salt. So double displacement reaction basically take place in the salt. So this is plus and minus, cation and anion. So cation will replace another one. So it will form A plus minus, and this is plus and minus again. So basically positive replace another positive, negative replace another negative. So a positive and the negative ion interchange in the salt form. So double displacement reaction, a reaction in which there is a mutual exchange. Mutual exchange means it is not forceful. They only decide mutually. Why they decide? Because of stability wise. So when we teach you kinetics and thermodynamics, you will learn there. So a reaction in which there is a mutual exchange of acid and basic radical. Acid and basic radical I have done for you, you know that. Is called as the double displacement or double decomposition reaction. In simple term, a compound where positive and the negative ions of two salts switch their position in aqueous solution basically. So for example, when I take HCl, that is hydrogen chloric acid in water, and NaOH in water, so what we see that H plus Cl minus Na plus OH minus, They will interchange their position. So H2O is formed and NaCl is formed. So positive, negative, negative, positive. These two combine. Similarly, when I take table salt NaCl and treat with silver nitrate, so they will exchange position. So this is Na plus Cl minus, this is plus and minus. The silver chloride will be formed and sodium nitrate, NaNO3. When I take copper sulfate, Cu2 plus, 2 minus, and H2S, this is plus and minus. Since it is 1 plus and 2 minus, that's why H2 we have written. They will interchange as copper sulfide and H2SO4. So sulfide means it is forming a black precipitate. What is precipitate in a layman term? Suppose you take water, you add curd into it and leave it. You see after some time the curd will settle down. So you can see a clear two different boundary, one curd solid and the water with turbidity up with dirtiness. That is precipitate. Or in layman term, if I want to explain you precipitate, you take beaker, you take a test tube and with water and take a cotton ball and dip into it. Cotton ball will absorb water and it will settle down in the bottom. That is nothing but the precipitate. Okay. So double displacement is basically between salts to replace the cation and anion. That's it from this one. So in today's lecture, I have given you the basic about mole. That don't get confused. It's just a number which is represented by 6.022 into 10 to the power 23. That number is named as Avogadro number. It's a very huge number. I have given you the analysis that 1 mole of donut will be how much. Then we have seen 4 different type of reaction. That is combination, where 2 things combine or more than 2 things combine. Decomposition, where things, a reactant break into smaller fragments. Then single displacement and double displacement. With reactivity series is important. So you learn from this. Again, we will do when we will teach you redox chapter. So that's all from the today's lecture or today's session. So 3 questions I am giving you from today. This will be a homework. This we will discuss next class when we come. So in the following chemical reaction, what product is represented by X? You need to find out X. So we have done today. You would have got it by now. So the chemical reaction chromium and iron nitrate is an example of which type of reaction, and the reaction is an example of which type of reaction. So these 3 are the homework for today. So please find this out, and we'll meet tomorrow in the next session. So hope you have understood. So wherever doubt was there, you can rewind back and go the back of the video and see the video again. So that's all from my side. Take care of yourself. Take care of yourself. Respect your parents and respect animals. And God bless you. Thank you very much.